Okay, so now we have our formulas. All right, so we're going to continue to manipulate our formulas. But in addition to that, in these problems, we're going to need to recall our exact values as well. Okay, so we have the sine of alpha is given, the sine of beta is given, and we're given information about alpha and beta. So let's check out what these mean. If alpha is between 0 and pi over 2, alpha is a first quadrant angle. And if beta is between pi over 2 and pi, then beta is a second quadrant angle. Okay, so that's going to affect the values of the trig functions, right? In the second quadrant, only the sine function is positive, which verifies what's given. But if we have to find the cosine value, then that's going to have to be negative. Okay, so the question asks us to find the sine of alpha plus beta. So sine of alpha plus beta, sine of the first angle measure, cosine of the second angle measure, keep the operation the same, cosine of the first angle measure times the sine of the second angle measure. Now when we look at what's given, we know the sine of alpha is 3/5 and we know the sine of beta is 24/25. So it's up to you to be able to determine what the cosine of these angle measures are. So that's where the information about the quadrants and good old Pythagorean identity come into play. So sine squared plus cosine squared equals 1. We also know, given our triangles, if we have a right triangle and we have an angle measure, then SOHCAHTOA comes into play. Okay, so either one of these things we would have to use on these types of problems. So if alpha is in the first quadrant, let's draw our triangle. Here's alpha. Sine is opposite side over hypotenuse. Hopefully now we're recognizing this as a 3, 4, 5 right triangle. So the cosine of alpha is equal to the adjacent side over the hypotenuse. So now, where I see cosine of alpha, I can replace that with 4/5. All right, now beta is a second quadrant angle, so we could draw it like the right triangles in the second quadrant. All right, opposite over hypotenuse again. You can verify here that the missing side length is 7 using the Pythagorean theorem. But now be aware that because this is in the second quadrant, technically I could write this length as -7. If you don't want to do that and you just know that in the second quadrant the cosine function needs to be negative, so the cosine of beta is adjacent over hypotenuse. So I'm going to replace cosine of beta with -7/25. Now we have to actually evaluate it. So top times top, bottom times bottom, plus top times top, bottom times bottom. All right, 3 times -7, 4 times 24. Adding these together, I get 75/125, and then reducing that fraction would equal 3/5. Okay, now given the tangent of angle measures, and notice here that alpha and beta are both between 0 and pi over 2, so they're both quadrant 1 angles, which is nice for you because in the first quadrant, all your trig functions are positive. Okay, you're looking for cosine of alpha minus beta. Cosine of the first times the cosine of the second angle. Switch the operation. Sine of the first angle times sine of the second angle. Okay, now here you're given the tangent function, so that doesn't help us with the sine or the cosine value. So let's go back to our right triangles. First I'll do alpha. Okay, tangent is opposite side over adjacent side. So here again, we have a 3, 4, 5 triangle. If I look at beta, opposite over adjacent side, and then using the Pythagorean theorem, you can verify that that hypotenuse is 13. Okay, so I have here that the sine of alpha, opposite side over hypotenuse, and the cosine of alpha, adjacent side over hypotenuse. And then in my other triangle with beta, I have that the sine of beta is 12/13, and the cosine of beta is 5/13. So now that we have each of these relationships, I plug it into my sum identity. So cosine of alpha is 3/5 times cosine of beta is 5/13 plus sine of alpha is 4/5 times sine of beta is 12/13. Okay, top times top, bottom times bottom, and then top times top, bottom times bottom. So the nice thing is that these denominators come out to be common denominators anyway, so you don't have to do any extra multiplying. So this would give me 63/65, and that would be your final answer. Now, once you have this information, we can ask you to find any of the sum or difference, right? We could ask you for sine of alpha plus or minus beta, cosine of alpha plus or minus beta, or tangent. Okay, so once you have all the relationships, then you just can plug them into the formulas. All right, given cotan of alpha and cotan of beta, alpha is a quadrant 1 angle, beta is a quadrant 2 angle. You're asked for the tangent of alpha plus beta. Okay, so from our identity, tangent of the first angle plus tangent of the second angle, all divided by 1 minus tan of the first angle times tan of the second angle. All right, well, this problem has the least amount of work of all of them. If the cotan of alpha is 3/4, then the tangent of alpha is just its reciprocal, so it's equal to 4/3. If the cotan of beta is equal to -1/2, then the tan of beta is just going to equal -2. That's reciprocal. So we don't need to use the right triangles at all to find our missing trig ratios. Okay, tan of alpha, 4/3, plus tan of beta, -2, all over 1 minus tan of alpha times tan of beta. All right, now the only reason I put it over 1 in the numerator is because you need common denominators here. Now I am going to, instead of doing that, when I look at the denominators of all my fractions, all the terms of this expression, the greatest common denominator would be 3. So I'm going to take that and I'm just going to multiply every single piece, every term of this expression by 3. So 3 times 4/3, the denominators would cancel. It would just give me 4. 3 times -2 would give me a -6. So therefore, I've eliminated the denominators in the numerator. Now down here, I think this makes sense to you, but don't forget to take the 3 and multiply it by the 1. So I have 3 minus. Now this is one term. So this 3 will cancel with this 3 here, leaving me with 4 times -2. So that'll give me a -8. So subtracting a -8, it would put a +8 in my denominator. So I have -2/11. And that would be my answer. Okay, last example for the video. Using the property and going backwards. So obviously it's going to be the tan of something, either addition or subtraction. So you have to look, this sign determines the sign of the identity. So since the numerator is being added, that means I'm going to be adding 2 angle measures. And the angle measures we can see from alpha, alpha, and then beta and beta. Okay, so alpha is going to be 3 pi over 4. Beta is going to be pi over 12. So I'm going to add those angle measures together. I need a common denominator of 12 here. So that would give me 9 pi plus pi all over 12. Whoop. This gives me tan of 10 pi over 12. And that'll reduce to tangent of 5 pi over 6. Now you actually have to evaluate it. So my reference angle is pi over 6. 5 pi over 6 is a quadrant 2 angle. Tangent is negative. And the tangent of pi over 6 is square root of 3 over 3. So that would be my final answer for number 4. Okay, that's it for this video.